So what is the flow through a siphon? These siphons are actually used to connect the tanks which are separated by a hill. So water will flow from this tank to this tank. So if the difference between the height of these two tanks is h, so the head loss, you can write this as h is equal to, because at the entrance there will be a loss, entrance to the pipe there will be a loss that is equal to 0.5 v square by 2g plus 4 FL v square by 2g due to the friction loss along the pipe, plus at entrance to this pipe you will have v square by 2g. So this is the total loss. So this will be equal to EH, the difference in head. So you can calculate the velocity here. But the problem occurs at the summit. The summit, at summit the pressure will be low because from here it has got a head, so it will move up, and here at the summit it will have a low pressure because of the head loss due to friction and also due to this elevation h. So what happens is that if the pressure is too low at this position, that means pressure falls maybe near to vacuum, that is minus 10.3 meter, it will cavitate, water will cavitate. Actually it may not reach minus 10.3. If falls below, that is at minus 7.6 meter itself, vacuum, bubbles will form, water will start to cavitate. So this is the problem with siphon. At the summit there will be problems like this. Now let us see the flow through pipe in series. You can see the two tanks connected here. So the tank is at a elevation difference of, two tanks are at a elevation difference of capital H, and water flows through these pipes, and you can see that first pipe converges to the a small pipe, and again it diverges, enlarges to another pipe. So if you write the discharge Q is equal to A1 V1 is equal to A2 V2 is equal to A3 V3. This is a one-dimensional continuity equation. Density remains constant. So the discharge through these pipes will be a constant. Now, how to write the H? This is the head difference. So this head difference is equal to 0.5 V1 square by 2g. This is the head loss occurring here at the entrance to the pipe, and we have a frictional loss, that is 4 FLV square by 2GD in the first pipe, and we have a sudden contraction loss that is equal to 0.5 V2 square by 2G, and then we have a sudden major friction loss, that is 4FL2 V2 square by 2GD2. And then we have a sudden enlargement loss, that is a minor head loss, that is V2 minus V3 the whole square by 2g, plus again a head loss due to friction, that is 4FL3 V3 square by 2gd3, plus it enters a tank. So again there will be a minor loss due to sudden entrance to a pipe, that is equal to V3 square by 2g. So the difference between a head of these two tanks will be equal to this total loss. So this is used to calculate the velocity of flow in a pipes which are connected in series, and also to find the head losses. In case you are neglecting the minor head loss, you can write the equation like this. H is equal to, you are neglecting all the minor losses. You will get, we are considering only the major friction loss. 4FL1 V1 square by 2GD1 plus 4FL2 V2 square by 2GD2 plus 4FL3 V3 square by 2GD3. Coming to the concept of equivalent pipe. You can see a pipe connected in series with a diameter of D1, D2 and D3 in series. Now if you want to replace this pipe with a single pipe of diameter, and if you want to calculate the diameter of the pipe, how to calculate the diameter of this pipe? For this, we will first write the continuity equation, that is the discharge through the pipe is equal to A1 V1 is equal to A2 V2 is equal to A3 V3, and this Q is equal to pi by 4 D1 square into V1 is equal to pi by 4 D2 square into V2 is equal to pi by 4 D3 square into V3, because area is equal to pi by 4 D square. So you can write V1 is equal to 4Q by pi D1 square, V2 is equal to 4Q by pi D2 square, V3 is equal to 4Q by pi D3 square. If you are neglecting the minor losses, you can write the head difference is equal to, start from here to here, that is the head loss. From this section 1 and 2, the head loss can be written as 4FL1 V1 square by 2G D1 plus 4FL2 V2 square by 2G D2 plus 4FL3 V3 square by 2G D3. This is the head loss. And if you substitute for V1 from here, you can substitute V1, that is 4Q by pi D1 square the whole square. Here also you can substitute here, and here also you can substitute 4Q by pi D3 square the whole square. And if you substitute that and take out 16FQ square by 2G pi square, you will get L1 by D1 raised to 5 plus L2 by D2 raised to 5 plus L3 by D3 raised to 5. And if you want to replace this entire pipe system with a pipe of a single diameter, the friction loss through that pipe will be with a diameter D and of same length of that of the earlier pipe system. You can write 4FLV square by 2GD is equal to 4FL by 2GD into 4Q by pi D square the whole square. This is equal to 16FLQ square by 2G pi square D raised to 5. And you can equate these two. If you equate these two, you will get L by D raised to 5 is equal to L1 by D1 raised to 5 plus L2 by D2 raised to 5 plus L3 plus L3 divided by D3 raised to 5. This L is actually equal to L1 plus L2 plus L3, the total length. So this is the concept of equivalent pipe. You can use this equation to find the diameter of a equivalent pipe, a replacement pipe. Now coming to flow through parallel pipes. You can see a flow through parallel pipes here. So the water is coming here, the discharge is Q. After this it diverges to Q1 and Q2. So this pipe has got a length of L1, diameter D1 and velocity V1, and here it has got a length of L2, diameter D2 and velocity V2. So parallel pipes are used to increase the discharge through the pipe. Here one thing you need to understand is that the head loss between these two pipes, between here and here, is constant. Whether it flows through here or here, the head loss between these two sections will be constant. That means the head loss through pipe L1 is equal to 4FL1V1 square by 2GD1. This is also equal to the head loss through this second pipe, that is equal to 4F2L2V2 square by 2GD2. And total discharge will be equal to Q1 plus Q2. And Q1 is equal to A1 V1 and Q2 is equal to A2 V2. So this concept can be used to solve the problems.